This is the third inequality video, and in this one we are going to solve absolute value inequalities. Now, just a refresher, if you use either one of these symbols, greater than, or equal to, it is a union. And if you use either one of these symbols, less than, or equal to, it's considered an intersection. So at the top of the page, it says to recall that to solve an absolute value inequality is first, you must isolate your inequality, or your absolute value, I should say, create two cases, and then solve both cases. So our first two examples are unions. So what we are going to do, we're going to do the first thing. It says isolate the absolute value. Okay, and our absolute value symbol is isolated. So just like when solving absolute value equations, I'm going to drop the absolute value symbol, write the problem exactly as I see it without the absolute value symbol. Then I have to create the second scenario. Now, to create the two cases, the second case, I need to keep the 5 minus 10a. I'm going to flip my inequality symbol and change the sign. That gives me the two separate cases. So now I am going to solve each one separately. So I'm going to subtract 5, which gives me negative 10, or positive 10, I should say, not negative. And then since I am dividing both sides by a negative, I am going to flip my symbol. In the second case, I'm going to subtract 5, which gives me negative 20 this time, and I'm going to divide by a negative, so I'm going to flip my symbol. Now, graphically speaking, I graph exactly what I have written down. So I'm going to put an open circle at negative 1. That's not negative 1. Let's try to find negative 1. There's negative 1. And I'm going to shade everything greater or smaller than, less than, negative 1. I'm going to also put an open circle on 2, and I'm going to shade everything greater than. So now my set builder notation for all real numbers a, such that a is less than negative 1 or a is greater than 2. And my interval notation would be the interval negative infinity to negative 1. That represents this part of the graph. Union that with 2 to positive infinity. That interval represents the second part of the graph. So I have done everything it said. I solved it, I graphed it, and I wrote each solution in interval notation. I also showed you set builder notation. In number 13, we're going to do the same thing. We need to write down two cases. So I'm going to write down negative 2 minus 8x greater than or equal to 30. And then I'm going to write negative 2 minus 8x, flip my symbol, change my sign. Okay, notice that the stuff that came out from the absolute value has not changed in any way. Both cases have negative 2 minus 8x pulled directly from the absolute value. So now I'm going to solve. I'm going to add my 2. That's negative 8x greater than or equal to 32. When I divide by negative, I flip my symbol and I get negative 4. On the second side, I'm going to do the same thing. I'm going to add my 2, which gives me negative 28. When I divide, I flip my symbol because I divide by a negative. You do not flip your symbol if you were dividing by positive 8. And then I get 7 over 2. So on my graph, I would put a closed circle on negative 4 and shade everything less than. 7 over 2 is equivalent to 3.5, so I need a number right there in between 3 and 4, and then I'm going to shade everything this way, solid dot between 3 and 4. My interval notation is exactly what I see, so negative infinity to negative 4 with a bracket because of the closed circle. Union that with a bracket on 7 over 2 all the way out through infinity. So I've done everything it asked. I solved it, I graphed it, and I wrote my solution in interval notation. Now, the second two examples are intersections. And if you pay attention to the way that we graph these, if you know for a fact that they are an intersection, you are going to end up with a special type of graph. Okay, so the first thing I need to do is add 4 because I need to isolate my absolute value. So I get the absolute value of x minus 3 is less than positive 4. Now I set up my two scenarios, my two cases. X minus 3 less than equal to 4, and x minus 3, flip my symbol, change my sign. So I add 3, I get x is less than 7. When I add 3, I get x is greater than or equal to negative 1. So I'm going to put a dot on 7, a closed dot on 7, and I'm going to put a closed dot on negative 1, and then everything in between those numbers will get shaded. When you do an intersection, the numbers that you shade have to work in the problem. Negative 8 will not work in this problem. Negative 8 is not shaded, so if I check negative 4 plus absolute value of negative 8 minus 3, it should be less than or equal to 0. That's negative 4 plus the absolute value of negative 11, which should be less than or equal to 0. That is negative 4 plus 11, less than or equal to 0. And 7 is not less than or equal to 0. That is a false statement. Therefore, negative 8 should not be a part of your solution set because it does not satisfy the given inequality. In number 15, we need to isolate the absolute value, So we're going to have to divide both sides by 8. You cannot distribute that 8. I know it's tempting, but these are not parentheses. This is absolute value, and they are a little bit different. So I'm going to divide both sides by negative 8. I get absolute value of 3 minus 3x greater than 15. Now I'm ready to set up my two scenarios, 3 minus 3x greater than 15, and 3 minus 3x, flip my symbol, change my sign. I'm going to subtract 3x, that gives me 12. I'm going to divide by a negative, so my symbol changes directions. I'm going to add my 3x, and that gives me negative 18. I'm going to divide by a negative, so that flips my symbol. I'm going to put an open circle on 4, negative 4, and I'm going to put an open circle on 6. Now, this inequality symbol is a union. It is not an intersection. It's a greater than problem. So I will shade less than, and I will shade greater than based on the solutions that I got. Now, my interval will be from negative infinity to negative 4, parentheses because the open circle, and I will union that with 6 to positive infinity. So be very, very careful that you identify what type of inequality that you are using once you get the inequality isolated. Do not make that judgment call until you isolate your absolute value. All right. 2 more examples, and then we are done with this. This should read less than equal to. That should be a less than or equal to symbol. So on this particular problem, I am going to multiply both sides by 4 to isolate the absolute value. So absolute value of 12 minus 4x less than or equal to 8. Now, I'm going to set up my solutions. This is less than, so it's an intersection. So I have 12 minus 4x less than equal to 8, and then I have 12 minus 4x greater than equal to negative 8. flip my symbol, change my sign. So I'm going to subtract my 12, and that gives me -4. I divide by a negative, so my symbol flips. I'm going to subtract my 12, which gives me -20 on this equation or inequality, and then x is less than or equal to 5. So I will put a solid dot on 1, I will put a solid dot on 5, and I will shade everything in between those two graphs or those two key points. My interval notation would be bracket 1 to 5. Number 17, we have a couple of things that we have to move. So before I decide whether this is a intersection or union, I have to get the absolute value isolated. So I'm going to add 5 first. I'm going to divide everything by 9. So that is 2 plus 6x less than 8. At this point, that is when I decide, do I have an intersection or a union? This is also an intersection. So I'm going to set up my two problems, 2 plus 6x less than 8, and 2 plus 6x, flip my symbol, change my sign. I'm going to subtract my 2, that gives me 6, divide by a positive, your symbol does not change. I'm going to subtract 2, which gives me -10, divide by a positive, your symbol does not change. So I am going to put a open circle on each one of these numbers. So an open circle on 1, and -5/3 is between -1 and -2. So somewhere in here, I need an open circle, and then you would shade everything in between. It's kind of hard to see, but you kind of get the point. Now, open circle on -5/3 is the smaller of the two numbers. So parentheses, -5/3 and 1. Always put the smallest number inside your interval notation first, because you're reading the graph from left to right, and the smaller numbers on the left, and it moves up to the bigger numbers on the right. So I hope this has kind of helped you with the absolute value inequalities. If you need any additional help, please make sure you contact me.